My dear students, in this video, two different types of machine tools, that is automatic and semi-automatic lathe, are explained. So before starting this explanation, I'd like to explain why we want to go for a semi-automatic or automatic machine tool. Because in conventional type of manual lathe, lot of limitations are there. In center lathe, lot of limitations are there, especially when we want to manufacture or machine similar or identical components of many types. For example, in batch production or mass production, the same or identical parts we will be making lot of numbers. So in each of this manufacturing, if we are using a conventional type of lathe, after completing each and every operations, we had to either we had to change the cutting tool, or we had to change the settings, or sometimes we had to unload the workpiece and reload another new workpiece. So all these things, that means all these things, loading, unloading, setting the machine and changing the cutting tool, all these takes too much time. So these time are non-productive time. So when we calculate the total manufacturing time or total number of pieces manufactured per unit time, that will be comparatively less. That means the production will be less for per unit time. Production rate is very less. So in order to improve the production rate, we had to minimize all these unwanted or non-productive time. For this purpose, we are using a semi-automatic or automatic machine tools. So the various modified lathe are, so after thinking about this automation, these two types of lathes are developed. That is turret and capstan lathe, then automatic lathe. These turret and capstan lathes are semi-automatic machine. The improvements are achieved basically in the following areas. So after implementing the semi-automatic and automatic machine tools, these areas we have improved. That means work holding methods have been improved. So simple methods are adopted so that we can immediately change the workpiece without much effort or time. Then the multiple tool availability, that means in the same machine we can load multiple tools, and each and every after each and every operations we want, if you want to change the cutting tool, it's also it can be changed. That means you can change over the tool. Then the automatic feeding of the tools, so tools can be automatically fed, so feed can be automated. Then automatic stopping of the tools at precise location, that means that you can set the stopper, you can adjust the stopper so that after after reaching a particular location, the machine will automatically stop the operations and the next operation will start. Then the automatic control of the proper sequence of the operations. So all these can be achieved by either implementing the semi-automatic or automatic machine tools. So these two are very important: semi-automatic lathe, capstan and turret lathe. A lot of similarities are there between these two machine tools, and there are some difference also. Turret and capstan lathes are the natural development of the engine lathe or center lathe, where the tailstock is replaced. So there is no tailstock in both capstan or turret lathe, and it is replaced by an indexable multi-station tool head that is known as turret. So there you can see a turret instead of a tailstock. This head carries selection of standard tool holders and special attachment. That means you can use this turret for holding the cutting tool, and it can be indexed. So indexing mechanism is also incorporated on this turret. This is a tool head. A square turret is also mounted on the cross slide in the place of usual compound rest. So As you know, in the conventional lathe, there is a carriage and compound rest. So in that position, we have another tool post with a square turret. That means we can hold four tools on the square turret. Sometimes a fixed tool holder is also mounted at the back side of the cross line. So total uh, we can hold six tools on turret. Six different types of tools can be held on a turret, and one tool on the back side of this tool post, and there is a square turret which is mounted at the front side of the workpiece, that is you can hold, you can mount on that for other cutting tools. So total 4 plus 6 plus 1, 11 tools can be held on the machine, ready to machine. All this can be used for machining. So that is one of the important thing in the both capstan and the turret lathe. So this is a schematic sketch to identify what are the important elements of this machine tool, semi-automatic machine tool. Here you can see the workpiece which is rotating on a chuck or a spindle, and here at the tail end of the machine you can see an indexing turret, that is hexagonal turret. So there are six faces, one, two, three, four, five, six. So on each face we can mount different types of cutting tools. Then here you can see the front side of the machine tool. There is again a square turret. This also can be indexed. That means here we have four faces are there. So four different types of cutting tool can be mounted on this one. Then one tool on the rear side of the machine. So total 11 tool can be held or can be mounted on this machine tool simultaneously. In contrast to center lathe, capstan and turret lathe are semi-automatic. So semi-automatic means some of the operations can be automatically done, and some other, for example, loading, unloading, setting of the machine, etc., we have to do manually. It possesses an axially movable indexable turret. So an indexable turret is one of the special element which is coming in the both turret and capstan lathe, and it is in the place of tailstock. It holds large number of cutting tools, or maximum 6 numbers of cutting tool can be held on this turret. And there is another 4 indexable tool posts on the front side and one in the rear side. And these machine tools are more productive for quick engagement and overlapped functioning of the tool. So that means the idle time or the non-productive time is reduced by using this type of turret and multiple tool holding devices. And it enables repetitive production of same job, that means identical components can be manufactured very easily, and these machine tools are relatively costlier and are suitable for batch production and mass production. So this is the schematic sketch of a capstan lathe. So I told you there are some similarities between capstan and turret lathe. So this is the capstan lathe. So here you can see headstock. This is just like a headstock of the conventional or center lathe, and this is the tool post, just a square tool post which is in front of the bed. Then in the place of the tail stroke you can see the turret is mounted on a ram or a slide. So here you can see a lot of lines, that is sliding ram. This is the sliding ram, and on the sliding ram you can see a hexagonal turret, and the sliding ram is mounted on a saddle. So saddle, by unlocking you can fix the saddle wherever it is required. Then machining will be done by moving this saddle, this ram or slide. So when we want to machine, the cutting tool is holding on this turret. So just move the ram in the left directions, that is towards the workpiece. Normally the workpiece will be holding here in the chuck or on the spindle. So the cutting tool will be moving towards the workpiece, so by moving this slide. So after one operations it will come back. Then while coming back, the indexing will take place and the next tool will face the workpiece. Like that this will be repeated. So this is the capstan lathe. So capstan lathe, one of the important differences, here there is a sliding ram. The sliding ram is absent in the case of turret lathe. So turret lathe, the turret or this tool head is just above the saddle. So there is no sliding ram. So the compared to this capstan lathe, the turret lathe is more robust, and it can do means larger workpiece can be machined on this turret lathe. So this is normally this capstan lathe is normally used for small workpiece. This is because of the sliding ram, the maximum movement possible is equal to the length of the ram. So here this is the photo of the a capstan lathe. So here you can see this is the headstock, and this is the spindle which rotates, and this is one of the tool holder, and this is the turret, six hexagonal turret here. Okay, so this is the turret lathe. The turret lathe, I told you that there is no sliding ram, so the hexagonal turret is directly mounted on the moving saddle. So if you want to give the feed, just by rotating this wheel, we can move the saddle. So the saddle move forward and backward. So while moving forward, the cutting takes place, and while moving backwards, the turret indexing takes place. That's all. So this is comparatively a stronger machine compared to the capstan lathe. This is more stronger and vibration will be less. This is used for heavy work. So this is one of the mechanism normally used in the capstan lathe. So as I told you, the capstan lathe, there is a sliding ram. So when the ram moves backwards, the indexing takes place. And similarly, this capstan lathe is normally used for machining a long workpiece which is inserted through the headstock. That means headstock spindle. The workpiece is there is a hollow headstock, and through the hole we can enter the workpiece. So this is the workpiece. Here you can see cylindrical workpiece. So this system is used for automatic feeding. That means the workpiece has to fed against the cutting tool or towards the cutting tool after each means after completing each operations. That means, for example, if the cylindrical workpiece is used for manufacturing bushes of equal sizes. So once you feed this long rod, you can start the machine, and after completing the entire operation of the a specimen or a product or job, that will be that will be separated from the raw workpiece or the job, and next operation will start, and that also will be completed. Like that you will be getting many number of identical components. So once you load the long bar, you will be getting, without any loading or without changing any settings, you can machine or you can manufacture different identical components. That is one of the advantage of this capstan lathe. So in the capstan lathe, the feeding of the bar or the job is by using this mechanism. So here this is very simple, means you can see this is the chuck. So this is actually coming in the here is the actually the cutting tool comes, the turret comes. So this is actually the spindle, or you can say this is the headstock. So this mechanism is incorporated in the headstock. So headstock, you can see there is a spindle, and at the end of the spindle you can see the collet check. It's not a three jaw check or four jaw check. This is collet check. So collet check, as you know, this it's when you press the workpiece, when you means you can expand it, slightly expand and contract, this type of collet check. So if you want to move the workpiece, if you want to move the workpiece through this collet check, the collet check has to be expanded very slightly, so that when it expands you can move, or you can push the workpiece from the back side. So this is done by using some mechanism. That is all. That is known as feeding. So feeding is nothing but it is moving the workpiece, moving the cylindrical rod after completing one operation, or after completing the product. Suppose if you want to manufacture many number of products, so one after completing one product, you can push the rod towards the cutting tool. So how it is operated, you can see here. Uh, this is the ratchet bar, and one of the important thing here it is, you can see a locking arrangement here. So this means this this is a feed collar. Feed collar can is there is, you can see here, and it is there is a locking screw is also there. So after inserting the job into this feed collar, it has to be tightened, so that when we move the feed collar towards the right side, it will push the workpiece also. And one of the speciality of this ratchet bar is it will only allow the forward movement, because of this inclination, this teeth here, it cannot, because it is locked, so it cannot move in the left direction. So the feeding will be only in right direction. So also we can set how much it has to move. That means after each operation, how much is the feed, that can be decided by adjusting the locking screw here. This is the stopper. So up to this stopper it can come. This feed collar or this column can come up to the stopper. So the position of the stopper can be adjusted by using this bolt. So what happens, suppose after completing the entire one operation, after completing the workpiece product, now suppose you want to feed the workpiece, then we have to, first of all we have to release or open the collar check. So collar check has to expand a little. Then after expanding, this has to be pushed. That means the pushing will be done by using this lever, wedge link. So when it is pushed in the this direction, so this will be coming towards the cutting tool. That means in the right side. So this is the feeding. So if you move this lever in this direction, that is anti-clockwise direction, so this will move towards the means towards the cutting tool side, that is turret side. So the workpiece will be moving forward. That's all. And we can control the movement etc by changing this pivot. All this we can control. So this is normally done by sometimes there will be some mechanism for pushing this lever. So when sometimes when the this feeding bar reaches a certain position, by using some lever, this will be moved. So when it moves, the workpiece will be giving feed to the workpiece, so that it will move towards the cutting tools for the next operations. So that is the operation of the feeding mechanism. So another important mechanism incorporated in the turret and capstan lathe is the indexing mechanism. Indexing mechanism, I told you that indexing is nothing but it is the it is the rotation of the turret head or tool head to a certain angle in the horizontal plane. That is, its axis is there, axis is vertical, and if the turret head or the it can move in the horizontal plane to a certain angle. That angle you can if there are six faces for this, that means hexagonal turret, then 360 by 6, that is 60 degrees the indexing angle. 60 degrees the indexing angle for a hexagonal turret. So after completing, for example, after completing the machining operation by a certain tool, suppose you want to execute another operation by using another cutting tool, then we have to index, that means we have to change the cutting tool. So the cutting tool, the next cutting tool will face to the workpiece. It will come in front of the workpiece. That means the turret has to turn 60 degrees. That can be done by automatically, as it is an automatic or semi-automatic machine. Indexing will be done automatically. So how this is done? Here you can see this is the elevation, the sectional elevation of the entire this turret and its housing. And in the bottom side you can see the mechanism of indexing is incorporated in the bottom, that is which cannot be seen. It is not in the top, it is below the turret head, below the turret head. And this is the plan view. This is the plan view. The mechanism includes, or the important elements of this mechanism are, two things are there. One is the this wedge, and another one is the lever. Wedge and lever. So here you can see this is the one which we have to rotate. Actually this is the bottom of the indexing head or turret head. So here you can see different pins, and this indexing lever will push the this bevel gear, not bevel gear, this indexing plate. It will push the indexing plate so that this will turn. So that means the base of the indexing head will turn. So this is normally done by using there is a locking arrangement. So always this will be locked by using a pole. Then first of all, before pushing by using this indexing lever, the lock to be unlocked. That is why we are using a wedge. So when the position of the wedge can be adjusted. So by means of this wedge, so when the this capstan ramp, sliding ramp, reaches at the position of this wedge, it will engage with the pole of this ratchet mechanism, and that will disengage. So that means it has been unlocked. Now we can turn the swivel base of the turret. So swivel base of the turret is can be turned by pushing, by using the indexing lever. So indexing lever is normally it is it you can set the position of the index lever and it is locked. So when the sliding ramp reaches here in front of this one, already this this is unlocked. That means pole is unlocked. Now we can freely rotate this swivel base. So this wheel base will be rotating in the anti-clockwise direction. In the anti-clockwise direction. Okay, so that the next tool will face the workpiece. So this will be repeated. Only the thing is, we had to settings takes too much time. That means we had to calculate, or we had to understand where this means the wedge and this indexing lever, etc., to be fixed. That is why trial and error we can do it. And these are stoppers. These are the stoppers. So this will actually control the reciprocation, or the stroke length of the ram. So this is actually the nut. We can rotate this bolt, and we can adjust the length. Okay. So these are the important two mechanisms incorporated in both the machine tools. So this figure explains how we can manufacture or machine a bolt from a cylindrical workpiece. So if a cylindrical workpiece is given, suppose you want to manufacture this bolt by using a turret or capstan lathe, then what are the important machining operations required? First of all, a turning operation is required. That means to reduce the diameter to 16 mm. So this is the 16 mm is the diameter of the tail end of the bolt. So this is the bolt head. A head is having more diameter, and this is the tail end. So we have to reduce the diameter of the tail end to 16 mm. So that means a turning operation is required up to here. So after getting the 16 mm, for example, one operation is, if it is sufficient, one turning operation, that means turning tool is used for reducing the diameter. After completing this one, the next one is we have to do a thread cutting operations. So as you know here, bolt there is a thread. So another tool is used for thread cutting, and another tool is used for chamfering here, for curving this one, end of the tool, end of the bolt. So lot of operations are coming together here. Now we will see this is the turret, this hexagonal turret. So here you can see each face is having different machine cutting tools. So here it is a bar stop, bar stop. That means this will stop here, and another one is box turning tool. So this is another tool, and end forming tool, then self-operating die head. So different tools are kept on the different faces. Understand? So whatever the machining required, we have to set this one. So this actually takes time. So once we set the cutting tool and the stopper, etc., in the correct position, then it is no time is required for manufacture. So one by one we can complete the manufacture. So that is the use of this semi-automatic machine. So here you can also, this also is clearly explained here, the indexing of turret and multiple different types of cutting tool mounted on the face of the turret. So here this is a workpiece. So here workpiece we need different operations. So all these operations can be completed by using these cutting tools. So after completing this one, the parting will be done. This is the parting of. That means this much piece, completed piece, will be separated from the raw material or job. And after removing this one, now feed has to be given. So the workpiece will be pushed by using automatic feed mechanism. Then the same operation again repeated, and then after completing this entire operations, you will be getting this part will be finished again, part of That means we can remove or cut this portion from the job. Like that we can complete the entire thing. Means whatever be the means the length of the workpiece, we can make that much number of components, identical components, by using the same settings. Then automatic lathe. What we have been explaining is semi-automatic lathe, that is turret and capstan lathe. The automatic lathe are those which machine the workpiece automatically. It's all the movement of the cutting tools, their sequence of application, feeding of raw material, parting of, and unloading the finished part. All are done by the machine. That means the manual work is very minimal. Most of the operations and changings, tool changings, then feeding operation and parting of, all that will be done by the machine itself. That is known as automatic machine tool. Two types of operations are required to be performed in metal machining. That is processing, actual cutting operation, then handling. Other than processing, that is non-productive process. The total time taken in the production of a component is the sum of these two, that is processing time and handling time. If we can make it very fast all this, that is handling of this workpiece, handling or setting machine, everything, changing the container, etc., we can complete the entire operations with the minimum time. That means the productivity of the machine tool can be improved. As large number of operations can be done by the machine itself, the operator will be free to utilize his time elsewhere. That means less operators are required. This is one of the example for the automatic lathe, single spindle automatics. It operates on a single component at a time. Commonly used single spindle automatic machines are sys type automatic screw machine and turret type automatic screw machines. These are the two examples of single spindle. Then sys type automatic screw machine. This machine is used for parts of small diameters. Longitudinal feed are obtained by moving the headstock with the bar instead of the tools. So here headstock is moved for giving the feed to the workpiece. We will see this one. So this is the uh, single spindle automatic lathe, single spindle. So here you can see one spindle is the one spindle. This is the headstock, and these are the turret, or where the tool head or the tool are arranged. So multiple tools are arranged on this space. So one after the other one, we can move this cutting tool towards the workpiece. So after these operations, it will go back to the original position. So the next tool will come, and the next tool will move towards the workpiece, and that operation will be completed. Then it will go back, like that, uh, in a sequence of operations. The entire workpiece completes the entire operations. That's all. So this is also represented here. This is the original machine. You can see this is the spindle, and these are the cutting tools in the radial direction. The radial directions. So multiple cutting tools are arranged. So this is very fast compared to the turret or capstan lathe. The operation is very fast. Entire thing will be done automatically. Turret type automatic screw machine. So here this is different. This is it has a turret. These machines are used for manufacturing screw, bolt, pin, etc. from the bar stock. These machines are capable of getting mounted as many as 10 different types of tools at a time. So as there is a turret, it can hold more cutting tools. Okay, this is also fully automatic. The only the difference is here the the tool holder is actually a turret head, which can be index. In this case, tool holder is not a turret. It is actually radially arranged. Radially arranged. The work, the cutting tools. Okay. Thank you.